Hey everybody, this video is going to talk about graphing a line given its equation in standard form. So here we have an equation in standard form, negative 5x plus 2y equals 6, and we're asked to graph it. Now, there's a few different ways we could do this. First way is to get it back into slope-intercept form so that we could do what we did in previous videos or on previous topics and just we're given the slope and we're given the intercept. Or we could plug in some points and see what happens. Let's plug in 0 for x, make a little table. If we plug in 0 for x, that's going to be negative 5 times 0 plus 2y equals 6, which means 2y equals 6, divide by 2, so y equals 3. So I have a point at 0, 3. Guess what? That is going to be our y-intercept, because it's right on that y-axis, right? Okay, but let's plug in, let's go ahead and plug in another point for x. What point do you want to plug in? Let's plug in, why not we just go ahead and plug in 2. So negative 5 times 2 plus 2y equals 6. Now we have to solve for y, right? So this is negative 10 plus 2y equals 6. So 2y, we're going to add 10 to both sides. 2y equals 16, so y equals 8. Wow, so at 2, y is 8. So another point we have is x is 2, y is 8. Let's do this another way and see if we get a similar thing. So, if we have negative 5x plus 2y equals 6, let's add 5x to both sides. So we get 2y equals 6 plus 5x. Now, slope-intercept form says y equals mx plus b, so let's divide by 2. So we get y equals 6 divided by 2. Each of these parts are divided by 2. I see so often students saying, oh, this cancels and makes a 3, right? But the 5x is also being divided by 2. So be careful. Y equals 3. I'm going to do the 5 halves x plus 3. So, my y-intercept is right here. That b value is at 3. Okay, that's good. And then 5 halves. So I'm going to go up 5. 1, 2, 3, 4, 5, and over 2. Either way, I ended up, those should connect. Either way, I ended up with the same line, right? So that is graphing a line given its equation in standard form.